Hello everyone, my name is Riku Ala-Laurinaho and I'm a doctoral candidate here at Aalto University. And my research interests include digital twins and data collection, and so is this presentation about digital twins and data collection. So, my claim is that digital twin needs real data from its physical counterpart to reach its full potential. And most of these features we are talking about are based on accurate information about the counterpart. And why this accurate here is red? Well, because Jari Juhanko said that I cannot use word accurate, because there's no such thing as accurate information. We always have some uncertainty with the data. So we should use word noun uncertainty information. And as Mika said, when we rehearsed, there's no output if we don't have any input. So digital twins really needs an input, and that input is real data. Of course, as there's a photo, we can have also simulation models, like visual components has this very accurate 3D model of the crane and kinematics model, but only with real data I think we can get the most benefit out of digital twin. Okay, so structure of this presentation. So first I'm going to talk about what we can do with the data and digital twin, and then I'm going to tell you about which kind of requirements we have for data collection. And finally I'm going to present a solution for this data collection, which I already showed you on the demo, so this sensor management system. Okay, so what we can do with data. First of all, we can confirm the simulation results. So when we are designing a product, hopefully we run some analysis. For example, if this structure can take these loads, and we can measure if these kind of loads we have calculated the model, if they match to the real world. So are we using the correct values for the estimated loads? Also, always some kind of assumptions are made when we are designing a product, and we can confirm these assumptions. For example, the same thing with loads. Maybe we say that we have 1,000 Newton meters load there, but with digital twin we can say that yeah, there actually is 1 kilonewtons load. Then we can analyze the use of the product. Is the product used as it's intended? For example, with crane, is the customer using the loads he said, or the customer said that they are going to use? And if we have fleet of data, of course the information gets more accurate, that we actually know that how our products are used. Then the optimization of operation is probably more important for the customer or who is using the product. For example, if we have this crane again, maybe we can track the routes of the crane, and maybe we can detect some unnecessary movement with that crane, and then maybe we can optimize those routes when we have traced those routes. And then maybe the most important part is that the real data is needed to couple really the physical product and digital product. For example, the visual components case, if we only had simulation model, yeah, it's cool, but when we have actually the data from OPC UA interface, it's really cool. So, and finally, this predictive maintenance we have talked a lot. So it's very interesting because of, for example, Kone gets something like 50% of its, I don't remember the word in Finnish, but liikevaihto is from services. And yeah, so optimizing the maintenance is very important task. Okay. So what kind of data is then needed? Well, it's a very difficult question. We can only give some guidelines, but in scientific literature it's sometimes stated that we should really mirror the physical product, but that's not feasible. We cannot collect that much data from the physical product. So what should be then monitored? First of all, we should concentrate on the weak parts, so the parts which are going to break first. And I hope that the manufacturer of the product hopefully knows these parts, But of course, we can also run simulations and see which are the parts which are loaded the most. So these parts should be monitored. For example, maybe brake is the first part to broke. Then we should maybe put accelerometer there to see if there are any excessive vibrations. And then the performance is important for the user of the product. So maybe we can, also for the manufacturer, we can measure if the product is working as we are meant to. Do we need to improve the product, or for example, install motors with more power or something like that? And well, then one approach is like adding sensors based on needs. So that's the approach we have taken with Ilmatar crane. So when we had this hook acceleration case, we just added accelerometer based on need and made the application. Then one interesting approach is to attach as many sensors as possible and see if we can get any interesting data, because there might be some stresses somewhere which we haven't think about, and then it's good that we have actually measured those parts. And finally, virtual sensors, and these sensors are like, it's basically calculating values based on some other values from other sensors. Okay, so requirement for for data collection. So first of all, we need that high quality data. If we don't have accurate or not known uncertain data, we cannot do much with it. So we need to have sufficient sample rate and sensitivity. Then adding a new sensor should be easy. For example, in this case, we did this hook acceleration case. It was just like 5 minutes to add the sensor to crane. So it's really fast, and then we can measure interesting things. And then my platform also supports changing the measurement setting from over the internet. So we don't need never kind of upload the code again. We can just change the settings from the internet. So this is interesting because we probably don't know what are the correct measurement parameters when we install the sensors. So it's really practical to be able to change the parameters afterwards. Then also network parameters change every now and then. So changing them is important. And finally, there's always some bugs in software. So changing software or fixing the bugs or adding new features is an important part of data collection. Okay, now we have this solution you already saw on the demo. So we have focused on easy, that's the keyword. So easy addition of new sensors, easy addition of new sensor types, and then the support of changing the measurement settings and network parameters over the internet. And then, as I showed you, the platform supports many application layer protocols, so it's a very versatile system. And yeah, multiple data formats such as Regatta and well raw JSON. And what's the hardware and software? So basically, this is based on like off-the-shelf components. So you can buy this Wi-Fi from the PyCom's website, and it's S32-based microcontroller, so very commonly used microcontroller. And I have used MicroPython for coding that. And then I already showed you the ADXL345 accelerometer, but then we have used those LiDARs to track where the crane is. And well, some of you may know Django. It's a very popular web framework, so the system or software is mainly based on Django. So the user interface is kind of made for humans, so it's easy to use from any browser, so it's publicly available on internet. But then this system has also a REST API. So the idea is that other systems can use this REST API to change the measurement settings of the sensors. For example, if we have this data collection in the Regatta platform, maybe the Regatta platform noticed that we need higher sample rate. So we can use API of this system to say that, okay, change the sample rate of this sensor higher. And where does the data go? Well, this system does not have anything to do with the data, so data is just sent somewhere. In this case, we have used the Regatta platform, which is actually quite good and very reliable at least, and we have some nice visualizations there. So the data analysis is done somewhere else, so this is just for the management of those sensors. And as I said, external systems can use this REST API to configure the sensors. Okay, so conclusion, well, data collection is an essential part of digital twin. And well, for example, the big machine such as crane needs a lot of sensors, so then we need a management system for changing some measurement settings and adding and removing sensors easily. And then we have this sensor management system as a solution. So the code is openly available on GitHub, so please download and use it and collaborate. And one word about future, we definitely need 5G. As we saw, the Wi-Fi doesn't support many devices per square meter, so 5G should support at least tens of times of devices per square meter or kilometer. Okay, that's my presentation. Thank you. Do you have any questions?
Thank you, Riku. Now time for questions from the audience. Do you know who he is?
So my question is that you were focusing on this physical level data, but we learned today that there are also asset level, fleet level, strategic level, and whole product lifecycle level data, and also legal aspects, regulative aspects. So my question that do you take or why don't you take into account those other layers of data, and how do you deal with the GDPR and other regulatory issues?
Good question. Well, this platform is just for collecting data with sensors. Of course, we want data from also other levels, but they kind of have nothing to do with this system. This system collects from the physical layer. Of course, we can have those 3D models or CAD models or FEM models where we can collect the data, and they add value also, but we also need this physical layer. So this is, well, how do I say it? This is kind of addition for those kind of data. And what about the legislation and GDPR? Those are very difficult questions, as we have discussed today. It's difficult to get permission to companies' very private data, which is very secret and part of their business model to have that data.
Actually, that's quite a good point, Tatu, what you brought into the discussion. If you add one sensor to the whatever product or process it is, so it might measure also the human activities and human behavior. So if the company has kind of GDPR policy and rules how to actually access maybe these legal issues, but it might be an issue to add a new sensor. That's correct. If there's no other questions, so I might add one. So now we talk about adding sensor and getting data, but as you have seen today, the metadata is as important, or even more important, in kind of systems where the data, one single data point, have multiple uses. So can you actually have access to the sensor data, to the uncertainty of the sensor type of data from this API?
Well, you can get the sensor information, and you can freely kind of save some data about the sensor on the metadata. Yeah, there is metadata, but it is not used for example, telling what's the accuracy of the sensor at the moment. But yeah, it is possible, but I don't know, maybe it should be more standardized way of doing that. And I think SmartCom is probably doing that right now, that they're trying to standardize the metadata. I don't know.
Okay. Any other questions? If not, thank you, Riku.